Hello all, myself Janil Popat. We are discussing consolidation. This is video part 3. In previous two videos, we have considered different theories of chapter consolidation, as well as we have understood clearly that what is compaction, what is consolidation, how are consolidation factors affecting the soil, and etc. Now, let us begin the numerical portion. First problem, in a laboratory consolidation test on a 20 mm thick sample of saturated clay from a site having 50% consolidation point was reached in 10 minutes with double drainage. Now, here there is a sample taken from site for laboratory testing and a 20 mm thick sample is there and 50% consolidation point in the testing was reached in 10 minutes with double drainage. So height should be considered as half. Estimate the time required for the clay layer of 5 meter thickness at the site for 50% consolidation. Now, if the layer was of 5 meter thickness and if you want to do 50% consolidation, then if there is drainage only towards the top, so it is a case of single drainage. How much time is required for the clay layer to reach 90% consolidation? So the time is asked. What is the time required for the clay layer to reach 50% consolidation if it was double drainage? So it is a complicated, complex problem. Let us solve it one by one. First of all, first thing to be found out is, let us see that degree of consolidation in the laboratory and in the field is same. It is always same. Now D1, as it is a double drainage, so 20 by 2 should be done, and it is 10 mm, so or 1 centimeter. In case of second sample D2 is 5 meter and that is for single drainage, so 500 centimeter, 1 centimeter and 500 centimeter. T1 time 1 was 10 minutes and we have to find time 2 T2, right? So let us find out T2 by T1 is equal to D2 by D1 square from theories. Now we have value of T1, D2 and D1, so we can find out T2. Value for T2 is coming out as 4.76 years. This is the first case. This is the first partial solution. Next, let us go to stage 2. Now, in the stage 2, U, degree of consolidation is 50%, which is lesser than 60%. So, we have to use formula TV is equal to pi by 4 U by 100 square, where we need U. U is given as 50%. So, 0.1963 will be TV. Now, for CV, I have TV now, I have T and D. So I can find out CV. For CV, I am putting all the values and I will get CV as 0.01963 centimeters square per minute. Be careful here about units. Some students make often mistakes in units here. Moving forward to on the field, D is given as 5 meter or 500 centimeter and U for 90% consolidation. We are asked that if 90% consolidation reached, then what will be the time required? So let us find out TV first. Now, as it is greater than 60%, I have to use TV formula like this: 1.7813 minus 0.933 log 10 base 100 minus U. Now TV is 0.848 according to that. Now TV I have that, CV I know that, and D is given. Now I can find out time required, small t. So putting all the values in the equation and finding out small t, which is time required, is coming out as 20.54 years. So this is solution, partial solution of item number 2. Let us move forward. Item 3. Time required for 50% consolidation with double drainage. So here two things should be noted. It is a double drainage case and consolidation should be 50%. So let us go ahead. Here I will use the same formula, T2 by D1 is equal to D2 by D1 square. But here D2 should be taken as 500 by 2 because of double drainage. So it will be D2 will be 250 centimeters. Now I have the value of T1 as 10 minutes, D2 as 250 and D1 as 1 centimeter. So I'll put all the values and I'll get T2 as 625,000 minutes. 6 lakhs 25,000 minutes. 6 lakh 25,000 minutes. Now it is converted into years. So it is 1.19 years. So that's it for this problem. Let us move forward to next problem. Problem 2. So, problem 2 states that in a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kilonewton per meter square, changed to 0.994 when the pressure was increased up to 429 kilonewton per meter square. Now calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility. So we have to find out three things. Find the settlement of the foundation resting on above type of clay if the thickness of the layer is 8 meter and increase in pressure is 10 kN per meter square. So data is given, all the necessary data is given, and three things are to be found out mainly. Let us write down given data first. So in this, we are provided with E0, initial void ratio 1.068, E that is 0.994, delta E can be found out, and I have found out delta E as 1.068 minus 0.994, and it comes out as 0.074. Sigma 0 dash, that is 214 kilonewton per meter square, which is provided initially, and then finally stress effective was 429 kilonewton per meter square. So delta sigma dash can also be found out with the same method. We can find out the gap between initial and final pressure, that is 215 kilonewton per meter square. Now let us find out first item, which is to be told AV, that is coefficient of compressibility. AV is equal to E0 minus E upon sigma dash minus sigma 0 dash, or we can say delta E upon delta sigma dash. So I have found out both the deltas, so let us write down values of deltas. So AV comes out as 3.442 into 10 raised to minus 4 meter square plus by kilonewton. Now this is my first thing. Second thing that is asked, that is compression index. Formula for compression index have been studied in previous video. That is Cc is equal to E0 minus E upon log 10 base sigma dash upon sigma 0 dash. Here I have E0 E value as well as sigma dash and sigma 0 dash value. So I can put all the values and get Cc value as 0.245. Now, moving forward to third item, coefficient of volume compressibility. So, for coefficient of volume compressibility, I will use formula that mv is equal to ab upon 1 plus e0. Now, I have ab, right? E0 can be written by 1.068. So, the value coming out from mv or coefficient of volume compressibility is 1.664 into 10 raised to minus 4 meter square by kilonewton. So these are basic three things. One more thing is to be asked is settlement of foundation. For settlement of foundation, we can use formula as we have shown in the previous video. SC is equal to CC into capital H upon 1 plus E0 log 10 base sigma 0 dash plus delta sigma dash upon sigma 0 dash. Now, let us write this. With this equation, I can write the values of H, E0, CC, etc. and I can get SC as settlement of foundation as 18.8 mm in this particular case. So, that's it for problem number 2. Let us move to problem 3. Problem 3 states that a clay layer 8 meter thick is subjected to a pressure of 70 kN per meter square. If the layer has a double drainage, do remember that it is having a double drainage, so depth to be kept is half, and it undergoes 50% consolidation. So consolidation percentage is 50%, and TP for that is 0.196 in 1 year. Determine the coefficient of consolidation. So we have to find out coefficient of consolidation here. If coefficient of permeability is given as 0.04 meter per year, then determine the settlement in 1 year. So it is a very specific question. Let us move towards solution, and hence it is a double drainage case. I will take depth as h by 2. H is given as 8 meter thick, so I will take B, depth, that is 4 meter. K is equal to CV into MV into gamma W. And for that, MV can be found out by putting value of K, which is provided, that is 0.04, CV, that is found out, and gamma W by default 9.81. MV can be found out as 1.3 into 10 raised to minus 3 meter square by kilonewton. Now, I will find out settlement. For settlement here, we will use formula SC is equal to MV into H into delta sigma dash. Here MV, we got that, H is provided, and sigma dash, delta sigma dash is also can be found out. So I am putting all three values and I am getting SC. Settlement as total settlement as in 0.728 meter. If I want to find out settlement in 1 year, then it will be 50% of total settlement. It is quite obvious. Now it will become 0.364 meters. So that's it on the problem number 3. That's it for this chapter, consolidation. Thank you.